I hope you can hear me. Hello, and welcome to this session. So I'll be talking about large language models and how they can address many of the financial challenges that we have. So it's more like what Sarah and Cleo team mentioned earlier. So you'll hear me talking about large language models, RAG, and all that. So but before we start the real talk, let me give you a brief introduction about myself. And excuse me for my cracked voice. It's because of the cold I caught 10 days ago. Now I'm recovering. And hopefully I can survive for next 20, 30 minutes without coughing. But that's not my introduction. So I started out chasing particles as a physicist at CERN, Large Hadron Collider. Then I joined Fermilab as a scientist. But then something happened. I took the sharp turn and ended up in insurance. And here I learned how AI magic can help us to bring valuable insights from complex insurance data because I ended up in insurance. But of course, you can use AI magic to any other data set. So this is where I found my new love, and I hope I'm going to stay here for until my end. And today I work for Gallagher. Gallagher is a publicly traded company. It's a world largest insurance brokerage and risk management company. But here is a heads up. Whatever I'm going to say, that's my own personal view. It has nothing to do with these large institutes or companies. So that's the introduction about me. But let's do the introduction to the talk here. So in next 20, 25 minutes, we're going to start with this pretty straightforward agenda. We have 4 points on our journey. First, we'll start with the introductions. We'll do a little bit introduction about what is large language model and how they can help us resolving these unique financial challenges that we'll see there. And then we'll start with why they are the game changers, and then what kind of challenges they will impose if we'll have to rely completely on these large language models. With closing on these introductions, we'll switch to the application of these concepts to an insurance use case. And then we'll see the real technical piece, which is about something like getting our hands dirty with the real customization of these large language models so that we could make them our own personalized large language models, feed them our own data, and they could respond to our own queries. And then we'll conclude with key takeaways and your questions then. So let's start with this why part, why large language models. So check this out, this cartoon here. So someone used large language models for writing a poem about their dog, and next day they want to change the entire business because they feel like it can do everything. But if you look at this survey, it's becoming the reality. It's no more a challenge, kind of. It is a challenge, but it's becoming the reality that this McKinsey survey is telling us that around 80% of us are using large language models, whether it's for simple daily use case, writing email or writing a poem for my 8th graders, or school essay or something. But we are using it for business applications as well. And this survey is telling us that businesses are relying on this too, these large language models. So large language models are no more just fun toys. They are not doing the points only, but they are becoming the real deal here. So the key takeaway is we should definitely start digging into them. We should start learning that how they can help all of us. So here in our financial world, so we have, here's the list of all these financial challenges that we see, starting from we want to analyze expenses year after year. We want to predict future costs. We want to do sentiment analysis on earning calls. Or towards the end, we have a list that we want to stay aligned or according to the rules that are set by either internal company guidelines, or there are some standard state regulations, federal regulations. We all have to comply there. So all these listed here, we can employ large language models to help us here. So all these financial statements, which are big unstructured documents, or this earning call statement, unstructured document again. So we can use generative AI, we can use large language models to fine reading, for predicting, for forecasting. And at the same time, the final part, which is staying on the line where our regulators want us to be. So as we can see that language models can help with many of the financial challenges. But why they are this such a big deal? Why large language models? So as you can think of large language models as a Swiss Army knife. So one knife can do multiple things. So here, one large language model, it can adapt to most of the business applications. You can apply it for writing simple email, or you can apply it to create a report. You can apply the same models to write the code, for developers. So they can adapt to your business need. They have the ability to process vast amounts of data really at a faster speed. They can generate text like human. So they talk to us like we talk to each other. And on top of that, everything is uniform. The results, the responses we get from them, they are efficient, uniform, and they can be scaled according to the business need. If we want to slow down something, we can. If we want to increase, we can. So it depends on operational needs. And on top of that, most of the manual work that we do within our compliance units, departments, we can employ these we can imply these large language models so that we could transform this manual workflow with help of these large language models. So these are the benefits of these models. But of course, it's not all sunshines and rainbows. So there are going to be challenges. So here's the list of challenges. You can see this cartoon here. In this cartoon, if we feel challenged with these large language models, so it's not about funny challenges. There are real cost, hefty computational cost-related challenges. So it's not that easy to deploy these. There are going to be, you have to have enough resources. And on top of that, you want to make sure that your data stays under the lock and key. You don't want to share your internal data. And on top of that, there was a question about model interpretability. So yes, we don't want black boxes. We want them to give us the clarity that the decision they made, how did they conclude that? We don't want these models to be biased. We want them to be fair to us. Of course, there is integration challenge. If we have to apply these models to our existing frameworks, will it be easy to integrate? I don't think it's that easy. So I have seen in my own business application, it's not that easy to integrate them. You have to write the front ends. You have to either attach to the existing frameworks. It's a challenge too. And on top of that, these big, large AI powerhouses, you need technical talent, real AI experts to steer these powerhouses. Okay, so, but as you can see, there's a lot to think about. But knowing these challenges, that's the only way that we can think about how to resolve them later on. So that's more like introduction to large language models. We have seen their benefits. We know there are going to be challenges. It's not that easy to apply to your application, but let's think about that and let's move on. So these concepts, now if we talk about the real application, so these concepts we want to apply now. And for this application part, we'll take the use case of staying according to the rules, internal rules or external rules. But this kind of manual work that we do, that our documents or financial statements, they should have some sort of structure. They should follow some sort of standards and internal guidelines or external guidelines. So this kind of application, which is more like looking into the your document, your insurance policy or your financial statement, and then checking that whether it's according to minimum standards, guidelines or not. So that's the application where we'll see that how we can employ large language models. So what's the benefit here? Of course, this will be automated process, and we're gonna hand over this to our compliance teams so that it could be more like a guidance tool to them, helping tool to them, not like replacement for them. So that's the application we'll discuss. And the example that we're going to take here is financial document. Here is more like, for me, it's because I work for an insurance company. So for us, we have to comply with this standard that insurance document should have minimum structure. It should have at least 5 these main sections, starting from declaration pages to you have to write down the endorsements, conditions, exclusions, all these sections. And on top of that, there should be clarity in your language, wording that you use. Excuse me. So this is the application where we can apply large language models that they could highlight that your particular document is missing. Here, as an example, effective date is missing, or one section is missing, condition section. We want large language model to highlight this particular part, this section, so that our compliance teams, they could look at that and they could modify if it's needed. Excuse me. Okay, so this is the application where we want large language models to help us. But how do we do that? How we gonna feed our insurance documents or our guidelines, our standards? So this is where we have already heard Clio team and Sarah talking about RAGs, retrieval augmented generation, but we can do fine tuning. But this is where this part comes in, that we have to customize these large language models. It's not that you're going to pick the default ChatGPT and you're going to ask your own enterprise content-based questions. It won't respond to your answers if it does not know about your data. So you have to customize it. So here's this pseudo flow chart. So what we want to scan our policy document here. We want to scan our guideline document, feed those scanned portions, extracted data to large language model, and then compare it, do the data analysis and comparison part. And on top of that, yeah, in the end, we want to analyze, evaluate it, that the responses are those according to what we wanted them to be or not. So evaluation is the final part. So this kind of process we want to deploy so that we could customize the generic pre-trained large language model according to our data. So for that, what do? We have to employ these strategies. One of them is RAG, which you have already heard us talking about in earlier talks. So it's all about large language model going out, doing sort of Google search according to your question, and then feeding that retrieved or searched portion into the context, and then synthesizing answer according to your retrieved portion, according to your query. So that's RAG, simple process. And if we want to be more fancy, we want to have our own language model, fine-tuned language model, which talks about our data only and should have the uh, should be trained on this specific use case. Let's say you want to do sentiment analysis. So you will do the fine tuning or something like that. So fine tuning is so far, according to my experience, is next level. But we'll stick with RAG because that can solve this problem of staying compliant, staying according to rules, or adhering to our standards. So RAG is our preference, but we should not conclude based on only one single application, which is here for me, staying compliant, conforming to standards. But it depends what kind of application you want to build. So here we can see this in this chart that RAG has its own benefits and fine tuning has its own. So fine tuning is preferable when you want model to behave according to your data, according to your task. And you have enough data, you have enough historical data that you could train your model, you could fine tune your model, then go ahead, do that. But if your needs, according to this other section, my needs section is that our compliance documents are updated every other day. So there are policy documents that there are going to be around 100,000 policy documents every other day. So my need here is to stay up to date according to the most recent data, most recent guidelines. And second need for me is I don't want this hallucination part here. And retrieval augmented generation, this is going to give you citations. It's going to give you the retrieved portion, that this is based on this retrieved portion. My answer is XYZ. So you will have citation. It won't act like a black box to you. Okay. Then my next need is, of course, I don't have enough training data, so I won't do that. Then interpretability is important, and my data is dynamically changing, and queries are changing. User questions are not like standard questions that is my policy compliant on exclusion section. This is a standard question, but there are going to be many other questions, so we cannot set up a proper process. We can, but there are going to be frequent questions. So my use case here is to build an application for my company so that we could support our compliance teams to do their task. So for me, RAG is the preference here because after comparing this, I got this conclusion that RAG is going to serve me. But these are not the only factors. We have many additional factors to consider. I'm doing the time. Okay. So talking about additional factors. RAG is scalable because of its modular nature. Then, but what's going to happen is that because it's going to go out to retrieve and then going to respond, so it's going to be slower. There's going to be latency in your responses. But on the other hand, fine tuning going to be really good, but you need extensive computational resources for doing that. Then there are going to be cost, of course, cost issues, complexity. Both of them are complex, but they have their own ups and downs. Of course, ethical issues. We have to talk about the training data that we use for fine tuning. We have to be sure that the data we save in our vector stores or in our databases, we don't save privacy information or all that part. So we have to consider all these other aspects as well. It's not that simple to deploy these models. Excuse me, my voice is dying. Okay. As I said, for me, for my purposes, retrieval augmented generation, this process is what I want to employ because this serves my need. So what is this RAG process? So it's really simple. As I have already mentioned, pick your document, chunk it, whether it's a sentence-based or paragraph-based or whatever you want to do, then save it somewhere. And then there comes this prompt assembly step that you have the user question, you retrieve the information based on that user question and feed it to your final stage of large language model that's going to synthesize your answer. So this process is the one that is helping me, that is supporting my entire application. And LangChain, as I mentioned here, this is my favorite framework so far. That's what I have used. So finally, this is not the end that you can employ RAG, but you want to improve the reasoning processes. So prompt engineering techniques are there. So you can read about that. You can improve the performance of these models by giving some hints to them, by employing chain of thoughts, tree of thoughts, or React or something. So React is the most fanciest one. So that's what we have employed, and it has served our purpose. So what did we gain out of this? So we wanted to support our team members, and we did that. And what we are getting out of this entire survey is that they find that this is improving their workload, and this is saving their time by 40 to 60%. And this brings job satisfaction, and they will love their job. That's why we are trying to employ this. So summary and conclusion. Main key takeaway is that, yes, they have, large language models have transformative potential. We can integrate them so that we could benefit from them, but we have to consider these ethical aspects. They should be accountable. They should be transparent. Don't deploy black boxes. And on top of that, in order to do all this stuff, you have to have your data, your content, your data. That is more important. And our institutes, our companies, they have to think strategically about content management. That is most important. So looking ahead, they are changing every day. So you have to stay tuned. So that's the presentation. Now we can start the question answering session. I'm not sure the time wise. Okay.
Thank you for the presentation. I'm curious, how do you define like the accuracies or relevancy of the result? Do you get the feedback from the user or?
Yeah, we have like Clio team had their evaluation framework. We definitely did that exercise with each and every division that we wanted to evaluate. Even that thumbs up, thumbs down part, we are employing that on each and every framework that we developed, that we could get the user feedback, whether it's serving the purpose or not. So yeah, evaluation frameworks, they have to be there.
Thumbs up, thumbs down, where you have like a scale.
We have 5 different metrics. It's something like sufficient. Is this answer sufficient to you? Is this accurate? Is this contextually correct or not? So there are these kind of 5 metrics that we chose.
Hi, I think while you were talking about RAG versus fine tuning, you had mentioned with fine tuning there was compliance concerns. Is that just with how often that the data is changing that you need to update it, or are there other hesitations for using fine tuning specifically toward compliance?
For compliance, I meant that let's say there are some sort of state rules that change every other quarter. Then you might want to retune your model every other quarter. But there could be some federal rules that don't change for 2 years or so, then we are good. But there are some internal documents that some sort of new law comes in and we need to update our guideline document, then you have to retune your model according to that. Yeah. Just feed in whatever is new, just read that. Yeah.
I was interested in your use of the React framework, and if you could give an example where it solved the problem for you that you weren't able to do without it.
So for us, React is like when you want to build reasoning along with actioning component, right? So for us, this entire RAG, we have deployed agents where agents are React based. So what we want to do, we want to compare the guideline document on one hand, and we have our policy document on the other hand. We're going to feed the entire RAG-based process to these agents. And then agents going to do the part of comparison. Remember, there was a third process flow step that we want to compare whether my document is according to XYZ rule or not. So when we do this comparison part, we want them to take the action. We want to say that is it compliant? Yes, no. What is wrong? Is this according to the Illinois state rules or not, something like that. So that action, when we say compare, that's where this actioning is, we have improved actioning component.
And this, I think it works better than trying to explain that process in the prompt.
So can you repeat your question?
Well,
please?
another way that people sometimes handle that problem is in the prompts, you give a series of prompts and responses to.
Yeah. So React plus chain of thought, we call it,
Mhm.
give some hints that that's how your response should be, and that's how your actions should be. When you compare number against number, 5,000 is less than 500,000. So we have tried this step too, that to compare, when you take the comparison of numbers, that's how you should act.
Mhm.
And you compare text versus text, that's how you act. So those few shots, along with chain of thought reasoning. So this entire prompt context, we have tried to improve. Yeah.
So you're using all three techniques?
So it's almost like same, right? React itself gonna be more like you definitely want to improve your prompt in a way that you could get response according to how you want it to respond. So you can impose as many things in the prompt as you want. You can just give some examples that question A would have answer A. So this is simple, more like simple example, few shots, right? One shot, two shot. And if you want to build the reasoning component, that here is the question. And when I ask for answer, you have to think that how answer is X, Y, Z. So you want to give in your example, the entire reasoning process. So that one example with reasoning, that is one shot with the chain of thought example. Then you give another shot, another chain of thought example. So this way you can have multiple examples,
Mhm.
but with reasoning inbuilt. And if you deploy agents on top of that, it will do the actioning part too.
And when you employ action, of course, you're increasing your risk,
And cost as well. And
cost and risk, right? Because if there isn't someone reviewing the action before it takes place, if it's all automated, I'd say you get cost advantages, but perhaps the risk of it going in the wrong direction. Have you found that happening, or have you been able to control it?
for now, for this one particular application and 2, 3 others,
Yeah.
we are controlling the tools, but yeah, those tools where we want these actions to take place, they can go out of hand. If we are sticking with Wikipedia, let's say, or we wanna say that, go ahead, do the Google search. So yeah, then actioning step based on those tools that we allow it to go out in the public. That could be public sites. That could be a concern, but for now we are trying to control it in a way that tools are specified by us.
So you're using it only internally,
Internal tools, yeah. Don't
And-
go out.
and
Don't.
you may have a person in the loop if it goes external, or do you think you?
For each and every application, person in the loop has to be there. Yes.
Okay,
Do not do anything without person in the loop. That's what we are experiencing.
okay, thank you.
We have time for one more? Hold on a second. We can check mic.
Hi, I want to ask you about two potential use cases. In term loan agreements and in some bond agreements, there's covenants where financial criteria needs to be met every time financial statements are available, usually quarterly as well as annually. And I'm wondering whether this information can be reiterated with large language models and automatically determine whether the loan agreement or the bond is in compliance with the covenants.
I agree. It's almost similar to what we are trying to build here. It's almost similar to what we are trying to build here, right? It's something that you have your bond agreement rules somewhere written in maybe a PDF document, or maybe it's written in a website. You want to read that, you want to extract that rule, and you want to then compare against your internal financial statements, that is it according to what this XYZ paragraph is saying. So yeah, so it is.
But have you done this before, or do you know if it's currently being used? The next one?
If there are public tools, I don't know, but of course we can apply the same concept to this another use case. The same
Okay.
use case here that we discussed, it's almost similar to that one, according to what I see right now.
Okay. The next one would be in parametric insurance, there's usually some trigger that would force payment to the recipient. And I'm wondering if the large language models can be used to analyze whether the trigger has been met or not.
Okay. Of course, I think whatever way there might be those triggered initiation processes there could be now today. We can replace with large language models, but it could be, I'm not sure, it could be overkill because large language models doesn't come without cost, right? So I'm not sure, but yes.
If you're not sure. Okay.
Yeah,
All right, thank you.
Thank you so much, Lavdeep.
thank you.